What's happening, everybody? In this video, I'm going to show you how to apply the newly learned power rule for derivatives. So let's do it. So the first thing you got to do before you use the power rule is rewrite the function that you are given as a polynomial. And in order to do that, you basically have to get rid of division by variables and things like that. So 2 divided by x to the second power is 2x to the negative 2. Because whenever you move a term with an exponent from denominator to numerator or vice versa, you have to make the exponent negative minus 4x cubed. So now that we have it written as a polynomial, in order to take the derivative, written f prime of x, we have to basically perform 2 steps on each term. Step 1 is to take the existing exponent and multiply by the existing coefficient. So here it's negative 2, the existing exponent, multiplied by the existing coefficient. So negative 2 times 2 would be negative 4. You rewrite the variable, and then you lower the previous exponent, which was negative 2, and lower that by 1. So negative 2 minus 1 is negative 3. And then same thing on this one. So existing exponent is 3 times current coefficient is 4, so minus 12. Lower the previous exponent by 1, so 3 becomes a 2. So that quickly we just found the derivative. Now the rest of this is all going to be algebraic manipulation just to show the different ways that this derivative can look. So I'm going to go ahead and do the first one and show you what it looks like. So what I did on that one was I lowered the negative exponent. I took that and I moved it back to the denominator. In order to get rid of a negative exponent, again, you have to move it from denominator to numerator or numerator to denominator, and that's how you get rid of the negative exponent. Here's another way you can look. So to get this one, I took the second term, which was negative 12x squared, and I turned it into having a similar denominator as the previous term, as the first term, negative 4 over x cubed. So I multiplied by x cubed on top and bottom, right here. So multiplied by x cubed over x cubed. And that's how I got this one. And there's one more. To get this one down here, I have basically just taken the 2 fractions and turned them into a single fraction. So the bottom line is what I'm showing you here is this. To get the initial derivative, not a lot of work using the power rule. But then there's so many other different ways you can rewrite that initial derivative. And why am I showing you this? Because sometimes when you're taking the multiple choice tests, there's going to be different forms of your answer. So you could do the derivative, get your answer, and it could be totally right. But it's not the answer that's going to show up on the paper. So now you have to try rewriting it a bunch of times. And even though I stopped at 4 different versions of this derivative, and all of them are equally correct, even though I stopped at 4, there's actually more. You can keep rewriting this in a bunch of different ways. So we're going to be practicing that over the next few weeks. So on to the next one, same first step. First we're going to rewrite by getting rid of that division by x. We're going to rewrite it as a polynomial. So all of these terms are going to be reduced by 1 power of x. So it'll go 3x cubed minus 3x minus 2. And from there, you're going to apply the power rule. So f prime of x, existing exponent of 3 times coefficient, so 9x, lower the exponent by 1, so 9x squared. Existing exponent of 1 times 3, minus 3, lower the exponent, so that becomes x to the 0. X to the 0 is 1, so I don't even need to put an x there. And then same thing here. There is no x term, so it would actually be written as x to the 0. So if I were to take the exponent and multiply it by the coefficient, it would just make this whole thing into 0. So this is it. This is our derivative. And a good eyeball test to know that you got the derivative right is to go back and look at, once you've rewritten the function here, you notice that it's cubic. And you notice that our derivative is quadratic. It's always going to be 1 step down. So that one was a little quicker. Which brings us to the last one. So same first step, but even before we write it, we're going to get rid of the radical in the bottom. So we're going to have 3x over, instead of the cube root of x squared, it's going to be x to the 2/3. And here's where you got to dust off your brain cells and remember the powers of exponents or the properties of exponents. When you've got a quotient of two exponents, you're basically going to subtract the two exponents. Quotient of two powers, excuse me. You're going to subtract the two exponents if the bases are the same. So this is a 1. So you got to think to yourself, what's 1 minus 2/3? 1 minus 2/3 is 1/3. So this is 3x to the 1/3. And now we're going to apply the power rule to that. So f prime of x equals existing exponent times coefficient, which would be 1. 1/3 times 3 is 1. So 1x, and we're going to do 1/3 lowered by a full integer. So 1/3 minus 1 is negative 2/3, which is x to the negative 2/3. And then if we rewrite that, that's the same as 1 over x to the 2/3, which, if you remember your properties of exponents, this is the same thing as 1 over the cube root of x squared. So this is correct, this is correct, this is correct. Those are three possible different ways to write that answer. And that brings me to the last one. And this one is already written as a polynomial, so we can go ahead and we can take the derivative right away. So f prime of x, 3/4 times negative 4 is going to be negative 3. And then we're going to lower the exponent by 1 full whole number. So 3/4 minus 1 is negative 1/4. And then plus 2 times 1/4 is 1/2. X, 1/4 lowered by 1 is negative 3/4. So that is a perfectly acceptable derivative. And now comes the fun part where we rewrite it a bunch of times. So all I'm going to do first is apply the properties of exponents. I know this is going to be negative 3 over the 4th root of x plus 1 over 2 4th roots of x cubed. And that step right there might be a lot to process. So if you have a concern as to how this term right here becomes this, that's something we should definitely talk about. So again, if I'm trying to rewrite, I'm looking at two different terms here with two different denominators. I've got negative 3 over the 4th root of x, and I'm wondering to myself, how in the heck do I get that thing to equal something over 2 4th roots of x cubed? So what's missing here? We're missing, from this first term, we're missing a factor of 2 in the front. So we're going to need to multiply by 2, for sure. And then how are we going to get it to be the 4th root of x cubed? Well, we're going to have to multiply by the 4th root of x squared. So we're going to have to multiply on top and bottom, so 4th root of x squared. And that will give me negative 6 4th roots of x cubed, of x squared, excuse me. So again, how did I come up with that? I knew there was a 2 missing from this denominator right here, so I had to multiply by that 2 here. And then how did I get from the 4th root of x equal to the 4th root of x cubed? I needed to multiply by the 4th root of x squared. So I did that up top, and it's basically just 2 times negative 3. So rewriting, we now have this first term being negative 6 4th roots of x squared over the 4th root of, over 2 4th roots of x cubed, excuse me, plus 1 of those 2 4th roots of x cubed. And then putting that all into one fraction and kind of rewriting a little bit, I have 1 minus 6 4th roots of x squared over 2 4th roots of x cubed. So the crazy thing about calculus is we were basically done right here. This was the derivative. And that's not that bad in my opinion, but then these are all different ways to rewrite it. This is the same, this is the same, and this is the same. These are the little things that, by getting better at these, we're going to see the most gains in this course. So that's it for now. I hope this helped, and I'll catch y'all later. Take it easy.